Good morning, Wonder Boy. Glad to see you survived the cosmic rays.
Hark! That building is falling! I'll catch it, don't worry!
Wait, Wonder Boy. It doesn't work that way. To stop the building from falling, Newton's first law states that we need to apply an external force. But is your mega strength enough to counteract the force of the falling building? Let's find out. We have to determine the force of the falling building. For this, we can use Newton's second law. Force equals mass times acceleration. That building must weigh millions of pounds, and because of Earth's gravity, we know it is accelerating downward at 1g. Once we have the acceleration and the mass, we multiply them to determine the force. This force is what you must overcome to stop the building from falling. With enough mega strength, you could fully oppose the falling force, and then some, allowing you to heroically fly off into the sunset.
So if I'm strong enough, then why can't I catch the building?
If we consider Newton's third law, for every action there is an equal and opposite reaction. Think about how much force the building is applying to your hands. Your hands are pushing back on the building just as hard. The problem comes when we consider pressure. Pressure is force divided by surface area. And the surface area of that building is huge compared to the area of your hands.
I suppose it's a little bit bigger. Or a lot bigger. Or a whole lot bigger.
With the great force your hands are applying to the building, divided by the small surface area of your hands, the amount of pressure is enormous. We see the pressure ends up being 500 times more pounds per square inch, or psi, than what water needs to cut through a steel girder, which is the strongest structure in the building. So, Wonder Boy, you would break right through it.
Holy buildings!
This would be just like stepping on a nail. The foot, moving downward, tends to continue to move downward until it meets the external force of the nail. The mass of the person, under the acceleration of gravity, applies a force to the nail. The nail exerts an equal and opposite force onto the foot.
I don't like where this is going.
Unfortunately, the nail has a very small surface area compared to the foot, resulting in a massive amount of pressure applied to the foot, breaking the skin.
Ooh!
A whole bed of nails, on the other hand, has a much larger surface area than a single nail. This reduces the pressure applied to the skin, preventing damage to the person. With our falling building, if we had hundreds of Wonder Boys, the opposing force would be divided by a much larger area, which would reduce the pressure and prevent the building from breaking apart.
Wowee! I sure like the idea of 100 Wonder Boys, but you're forgetting one way this could work, Captain Awesome.
I am?
We simply don't live in the real world.
Ha ha ha. Right you are, Wonder Boy. Right you are.